2.3 more equations. We're going to take what we've learned about the 5 steps for solving equations, and we're going to do it with equations that have fractions and with the ones that have decimals. And we're going to add a step to our 5 steps. What I want to do here is I can work with the fraction, or I could get rid of it. And that's what I want to do, is I want to eliminate the denominator. If I take a number and I multiply it times its denominator, that whole number is at the top of a fraction. And then these two, top and bottom, cancel because they become 1. And then all I'm left with is the 4. So that's what I want to do here. I look at the denominator, and they could use a 5 as a common denominator, so I'm going to take and multiply everything here by 5. So I'm going to have 5 times 4/5 x plus 5 times 2/5 equals 5 times negative 6 over 5. Remember, this 5 is over 1, so that those cancel. Over 1, top and bottom, those are the same. They cancel. Left with the 2. Top and bottom again. Over 1, cancel. I'm left with negative 6 over 1, which is negative 6. Move that constant. Divide by that coefficient. X equals negative 2. Of course, we're going to check it. We have 4/5 times negative 2 plus 2/5 equals negative 6/5. This would give me negative 8/5, because that again is over 1. Signs are different, so I subtract and I take the sign of the larger number, and we have something that equals. So then I know that this answer is correct. Eliminating the denominator. Let's look at another one. Here we have x plus 24/9 equals 1/3 x. If I had to get a common denominator, I'd have to pick 9. 3 will go into 9. So I want to multiply everything by this 9. So it'll be 9 times x plus 9 times 24 over 9, and 9 times 1/3 x. Here, 9 top and bottom will cancel. Here, 9 is at the top and 3 is on the bottom. Won't cancel, but I can divide it. 9 divided by 3. 9 at the top and 3 at the bottom would give me 3. So I have 9x plus 24 equals 3 times 1x. I need to move a constant. Now, if I move the smallest in this case, then everything ends up over here. So to save me a couple of steps, I'm just going to go ahead and move. Well, I'll save one step, end up with a bigger one, or just a one to replace it. That becomes 0. Now I end up with a negative x, but I still have to divide with that 6. So divide both sides by negative 6, divide by negative 6. and x is going to equal a negative 4. Then let's come over here and check this. We've got negative 4 plus 24/9 equals 1/3 times 4. So, negative 4 plus 24/9. Go ahead and write this over 1 because we're talking about fractions. 4 times 1, and remember that's over 1. 3 times 1. Need a common denominator. We'll use 9. I'll change this, so this is going to be 9. That's going to be 36. That will give me a negative 12/9. Not equal yet. But when I go to reduce this, let's see. Am I missing a negative somewhere? Ah, yes, here. This is supposed to be a negative. My answer says it's negative 4. So negative 4 here for x, and negative 4 here for this x. So this should be negative, 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 divide by 3, divide by 3. That means this is right. All right, when we're looking at proportions, proportions are two fractions equal to each other. What we're going to do to simplify is we're going to cross multiply. Alright, so let's get this written down. At the top we've got 9 times x minus 3 over 6. 3 times x plus 4 over 9. We have two fractions equal to each other. We could even have the case where we have one fraction equal to, we could get rid of this. And we would still do the same thing, the same process. So, even if we don't have a fraction here, we're going to, we'll kind of combine this and what we did earlier with something like this. But for now, let's leave this. I'm going to take and multiply these two and these two. And I'm only multiplying the numbers in front here because then they'll be distributed with what's inside. So I'm going to have 9 times 9, x minus 3 equals 6 times 3 times x plus 4. And so we'll go ahead and do this and this. Order of operations says I can. And then we'll finish out our equations. That's 24, 10x, 32, 72. Hope I did the math right. Alright, so now we've got to start moving some things. I'm going to minus this 18x, minus the 18x, 81 minus 18, 16, 63x minus 243 equals 72. Then we want to move the 243, so plus 243 so that this will cancel, plus 243 we're left with 63x is going to equal 5, 7, 8, 9, 10, 11, 315. Now we're ready to get that x by itself. Divide by 63, divide by 63, and x will equal 5. Check it. I'll tell you what, I'm going to let you do the checking. So pause. Do the checking, and then come back and see if you got it correct. That's 18. Three equals 3. It checks. Very good. All right. In our last section, I think it was our last one, where I asked you if 0 could be an answer, but we couldn't have a 0 variable. We're going to look at a couple of special answers. You won't have these often, but you're expected to recognize them. So this may be something that you want to stick on put on a 3x5 index card just to keep in front of you while you're doing your homework, along with those steps to solving equations. Alright, we've got 6 times 2x plus 7 equals 12x plus 42. And what we have here is we're going to do the distributive property, so I'll have 12x plus 42 equals 12x plus 42. And at this point, if you recognize that that is the same, then you could go straight to your answer. But let's see what happens when I finish it out. Let's move this 12x to the left. That becomes 0. And so does this. So I'm left with no x's. If I move the 42, so all I've got left now is I've got 42 equals 42. And that's true. So I can stop here also and say, you know, here's my answer. If you still don't see it, then, you know, you still want to move it. Minus 42, sorry, wrong color. Minus 42 on both sides, and you'd end up with 0 equals 0. Again, it's a true statement. Your special answer here is all real numbers. Any number we pick for x will make that a true equation. Let's look at another one that has a special answer. Gotta do the distributive property again first. Now at this point, if you notice, we've got 4x on both sides. When I go to subtract that, minus 4x, that becomes 0. Minus 4x, that also becomes 0. What I'm left with is minus 8 equals negative 4. And this is a false statement. So when this is false, when it gives you a false statement, then your answer is no solution. We can't pick a number for x that will make this a true statement. Here we can pick any number we want, and it will become true. Okay? All right. Let's look at some more equations. If we have decimals in an equation, we have the same choice that we have with our fractions. We can work with them or we can get rid of them. So if we want to here eliminate the decimal, we would do it first. And we're going to concentrate on the place value. We've got tenths, tenths, tenths. If we had hundredths, we'd have to take that into account. I'm going to take and multiply this all by 10. That'll make all of those decimals move over one space. You should remember this from, oh, I don't want that decimal. You should remember this from the past. If I have 33.4 times 10, that's, if I take and multiply 34 times 10, 340, one place behind the decimal, I get 34. But just knowing that 10, that 1 0 there, it makes that decimal move one place. Alright, now I'm back to working with whole numbers, and we all like that. So we want to minus the 34, minus the 34. So 22x is going to equal a negative 132. Then we want to divide by the 22 to get this x all by itself. Divide by the 22. And x is going to equal a negative 6. Now, even though you do eliminate, let's just give you a little note. When you eliminate the denominator or the decimal, you can still get a fraction or a decimal for an answer. So that's something to keep in mind here. So if you do happen to get a decimal or a fraction, even though you got rid of them, you can. Just like we said, you can have 0 for an answer, but you can't get rid of all the x's. All the x's and y's can't disappear. Alright, so go ahead and try this section, 2.3, and I will have another video for you, 2.5.